limit h tends to 0, instead of x, what we put? 1 minus h. So limit h tends to 0, 5 minus 5h minus 4. 5 minus 4 is 1. Put the limit h tends to 0, 5 into 0, 0. Now right hand limit. Limit x tends to 1, positive. When x is greater than 1, 1 is less than x, it means x is greater than 1. When x is greater than 1, then the function has value 4x cube minus 3x. Now limit h tends to 0. Since positive limit, right hand limit, so instead of x, what we put? 0, 1 plus h cube minus 3 into 1 plus h. Clear? So we can write it as limit h tends to 0, 4 into 1 plus h cube minus 3 limit h tends to 0, 1 plus h. Now solve the limit. 1 plus 0, 3, 1 plus 0. 1 cube is 1, 4 into 1 minus 3 into 1. Now value of the function at x is equals to 1. When x is equal to 1, then the function has value 5x minus 4. So instead of x, put 1 here. 5 minus 4 is 1. Now left hand limit is equal to right hand limit is equals to value of function at that point. Therefore, the function is continuous at x is equals to 1. Discuss the continuity of the function given by f of x as modulus of x minus 1 plus x minus 2 at x is equals to 1 and x is equals to 2. We have to check the continuity of function at both points when x is equals to 1 and x is equals to 2. We know that modulus of x has value negative when x is less than 0, value positive when x is greater than 0. Clear? Now, when we have to check the continuity at both these points, so when first case x is less than 1. When x is less than 1, then modulus of x minus 1 will be negative. Since x is less than 1, 1 से कोई भी term छोटी है, it means that will be less than 2, 2 से भी छोटी होगी, तो हमारे पास इसका modulus क्या होगा? That will also negative. So minus x minus 2. Clear? I am again repeating. We know modulus of x is negative when x is less than 0 and positive when x is greater than 0. We have to check the continuity of this function at 2 points, 1 and 2. So first is the case when x is less than 1. When x is less than 1, then modulus of this function will be negative. कोई भी term जब 1 से छोटी होगी, so that will be less than 2 also. So modulus of x minus 2 is also negative. Now next is the step. We have to check 1 is less than equals to x less than 2. x जो है 1 के इक्वल है और उससे ग्रेटर है बट 2 से छोटा है. जो x की वैल्यू है वो 1 से तो बड़ी है बट 2 से छोटी है. Clear? When x is greater than 1, then modulus of this function will be positive, but x is less than 2, so this value will be negative. Clear? Now next is the case when x is greater than or equal to 2. X is greater than or equal to 2. X is greater than or equal to 2. 2 से बड़ी है तो 1 से भी बड़ी होगी. So this is positive. 2 से भी बड़ी है, so this will also positive. Now we get the value of function 1. X plus x 2x minus 3 when x is greater than equal to 2. So this is the value of function. सबसे पहले हमने क्या किया, फंक्शन को सॉल्व किया to get the value of function. Now we want to check the continuity at 1 and 2. Left hand limit 1 negative. When x is less than 1, function has value minus 2x plus 3. We can write it as limit h tends to 0 minus 2 instead of x 1 minus h plus 3. We can write it as limit h tends to 0 minus 2 minus minus plus 2h plus 3. 3 minus 2 is 1. Put the limit h tends to 0. So we get the answer as 1. Now right hand limit. Limit x tends to 1 positive. When x is greater than 1. Greater than or equal to 1 के लिए हमारे पास function की value क्या है? 1. So right hand limit is 1 and value of function at 1 is also 1. Now left hand limit is equals to right hand limit is equals to value of function at that point. Therefore function is continuous at x is equals to 1. Now we'll have to check the function's continuity at point x is equals to 2. So for x is equals to 2, left hand limit x tends to 2 negative. When function has value x is less than 2, then 1. Left hand limit is 1. Now right hand limit x tends to 2 positive. Then we have value of function as 2x minus 3. So we can write it as limit h tends to 0, 2 into 2 plus h minus 3. 2 into 2, 4 plus 2h minus 3. 4 minus 3 is 1 plus 2h, 0. So 1. So value of function at x is equals to 2. 2 into 2 minus 3. 4 minus 3, 1. Left hand limit, right hand limit and value of function at that point is equal. Therefore function is continuous at x is equals to 2. Therefore function is continuous at x is equals to 2. Is it clear? Let's move to the next question now. Determine the value of k for which the following function is continuous at x is equals to 3. F of x is value x square minus 9 x minus 3 when x is not equals to 3 and has value k when x is equals to 3. It is given that function is continuous at x is equals to 3. Since function is continuous at x is equals to 3, it means left hand limit is equals to right hand limit is equals to value of function at that point. Value of function at x is equals to 3 is given k. Now we have to find left and right hand limit. Limit x tends to 3 negative x square minus 9 upon x minus 3. अगर हम इसमें डायरेक्ट x tends to 3 पुट करते हैं, 3 square is 9, 9 minus 9 0 and 3 minus 3 0. This is of 0 upon 0 form. So सबसे पहले हम क्या करेंगे? Let's factorize the term in numerator. A square minus b square. A minus b, a plus b. Now it will get cancelled. So limit x tends to 3 negative is x plus 3. So we can write it as h tends to 0, 3 minus h. Instead of x, 3 minus h. plus 3, 6 minus h, limit h tends to 0. So 6 minus 0, 6. Now right hand limit x tends to 3 positive, यहाँ तक सेम होगा. So हमारे पास क्या बचा? x plus 3. h tends to 0, 3 plus h plus 3. 6 plus h, limit h tends to 0. So 6 plus 0 is equals to 6. Left hand limit, right hand limit. So we get the value of k as 6 when the function is continuous at the point x equals to 3. Now the next one. Find the value of constant lambda so that the function given below is continuous at x is equals to minus 1. And the function given is f of x as x square minus 2x minus 3 upon x plus 1. X is not equals to minus 1 and lambda when x equals to minus 1. अगर हम देखें when x is not equals to minus 1, so x is less than minus 1, left hand limit, minus 1 negative, function as this. क्योंकि अगर हम x को minus 1 यहाँ पे पुट कर देंगे तो डिनोमिनेटर क्या हो जाएगा? 0. Minus 1 square, 1, minus minus 2, this will be of 0 upon 0 form if we put x as minus 1 here. So first what we have to do? First we have to split the terms. So factorize it. On multiplication we want the term minus 3 and on adding and subtracting we want the term minus 2. So we can write it as minus 3x plus x upon x plus 1. So first हम इसे factorize कर लेते हैं. So what will we get? x minus 3 plus x minus 3 upon x plus 1. X minus 3 is a common factor. X plus 1 upon x plus 1. X plus 1 will get cancelled. So we are left with x minus 3. Now if we put left hand limit, x tends to minus 1 negative, limit h tends to 0, minus 1 minus h minus 3, minus 1 minus 3 minus 4 minus h tends to 0, so we get answer as minus 4. Now right hand limit, x tends to minus 1 positive, so minus 1 plus h, minus 1 minus 3 minus 4 plus h, limit h tends to 0. So minus 4 plus 0 minus 4. So minus 4 equals to minus 4 is equals to lambda. So we get the value of lambda as minus 4. Now the next one. Find the value of the constant k so that the function given below is continuous at x is equals to 0. 1 minus cos 2x upon 2x square. X is not equals to 0. K when x is equals to 0. We can also solve these types of questions like when f of x is continuous at x is equals to 0, it means limit x tends to 0, f of x will be equal to f of 0. Means left hand limit, right hand limit, limit of function at that point is equals to value of function at that point. So we will solve it as limit x tends to 0, 1 minus cos 2x, f of 0 is k. Now cos 2x के लिए हम formula use करेंगे. Cos 2x is 1 minus 2 sin square x. So 1 minus cos 2x is 2 sin square x. So instead of 1 minus cos 2x, because if we put 0 here, so cos 0 is 1. 1 minus 1 0 and 2 into 0. So 0 upon 0 फॉर्म बन रही है. इसलिए हमने क्या किया, इसका फॉर्मूला यूज किया to convert it into other type. So 2 sin square x upon 2x square. So it will get cancelled. So limit x tends to 0. We can write it as sin x upon x square. Limit x tends to 0. Sin x upon x has value 1. So we get the value of k as 1. Find the value of a if the function f of x defined as 2x minus 1 a x plus 1 when x is less than 2, x is equals to 2, x is greater than 2 is continuous at x is equals to 2. Given that the function is continuous at x is equals to 2, but here for less than 2 and greater than 2 function has different values, so we will have to solve left hand limit and right hand limit. Limit x tends to 2 negative, function has value 2x minus 1. 2 into 2 minus h minus 1. 2 into 2 4 minus 2h minus 1. 4 minus 1 is 3. Put the limit h tends to 0. Now right hand limit. Limit x tends to 2 positive. Then function has value x plus 1. Limit h tends to 0. Instead of x, 2 plus h plus 1. So limit h tends to 0. 3 plus h. Put the limit h tends to 0. So value of function at that point is a. Given that function is continuous at x is equals to 2, left hand limit, right hand limit, value of function at that point. Therefore, you will get value of a as 3. If the function f of x defined by log of 1 plus ax minus log of 1 minus bx upon x, if x is not equals to 0 and k, if x is equals to 0, is continuous at x equals to 0, find the value of k. It is given that function is continuous. Now for x is less than 0 or greater than 0, the function is not different. So we will use this formula. Limit x tends to 0, f of x is equals to value of function at that point. 0, limit x tends to 0, log of 1 plus ax upon x. If we write it as this, now we know that limit x tends to 0, log of 1 plus x upon x. Log of 1 plus x upon x has value 1. Here we have ax, so multiply and divide here by a. A log 1 plus ax upon ax. And here negative of bx. So plus here negative in the denominator, multiply and divide by b x log of 1 minus bx. Now अगर हम लिमिट सेपरेट कर दें, प्लस लिमिट x टेंड्स टू 0, So this is 1 into A plus 1 into B is equals to value of function at that point, that is 0. A plus B is equals to K. F of 0 is K, not 0. So A plus B is K. So the value of K is A plus B. Find the values of A so that the function f of x sin square ax upon x square when x is not equals to 0, 1 when x is equals to 0 is continuous at x is equals to 0. Given that function is continuous at x is equals to 0, therefore we can write it as this. Now limit x tends to 0, f of x is sin square ax. Here we have x square, so multiply and divide by a square. Value of function at x is equals to 0 is 1. So limit x tends to 0, we can write it as sin of ax upon ax, sin square and ax square is equals to 1. Limit x tends to 0, sin x upon x is